So
Okay, perfect. Hey, everybody. So yeah, this is a nice small group, which I like. So the talk, if you have any questions anytime through, or there's gonna be a couple times where I'm gonna ask you questions, feel free to speak up. It'd be great. So hello, my name's Kody Fintak. I'm a code crafter, developer. Right now, I'm a software coach, working with Anthony at Industrial Logic. Um, my talk today is about a really cool collaborative programming style that incentivizes taking small steps together that I kind of stumbled across with my colleague Brett Schuart, called trunk-based ping pong. That is different than TDD ping pong, I shall add. And we will talk about how it's different later. So it's a different, cool, new thing. All right. So here's the resources for the talk. I'm also going to have this at the end, but it's kind of a little markdown file with all the links and everything. But to start off the talk, we've got to think for a little bit. So everybody, which ladder would you prefer to climb?
I feel like this is a trick question, but I'll say left.
All right. Two for left.
Yeah,
Okay.
the left or dark ladder. Dark
Okay.
ladder.
Who do we think's going to make it to the top faster? Left. I agree. Why?
Smaller steps.
Yep, which is part of what I kind of preambled the talk with. But the left side is a lot less risky. I mean, if you look at the right, that guy's fully reaching out and he's not even hitting the peg of the ladder yet. So we're talking about that person probably has to run up the wall a little bit and then grab the ring of the ladder to actually even get up there. The left side, it's very effortlessly grab the next one, and we can lean on the previous steps below with our other limbs. So which ladder looks more like software development in typical organizations?
Right ladder.
Yep. Why is that?
Because they do a whole bunch of, one person does a whole bunch of code writing and then smooshes it out into the world all at once.
it's not worth taking all those going up those little rungs. We might as well just do the whole thing.
Yeah, I agree. It's faster, right? You can just jump right up.
There's fewer steps. What's not to like?
So I think what's interesting about this metaphor, and I stole this from a LinkedIn post I saw with Dragon. And there's really great discussion in there. It's in the references, but at least I love this metaphor because it applies to most of software development. So we're talking releases. What's riskier? Doing giant releases like that or doing lots of small little releases? Integrating our code together. Should we integrate our code together where we feel like we're going weeks on end before we integrate, or should we be integrating every day, every hour, every couple minutes? So it has to do with balancing risk and actually trying to go steady. Like in that post, Dragon says, I think it's Dragon or somebody else. They say slow equals steady and steady equals fast. That probably comes from somewhere else, but I really like that saying. But really, the right is an example of biting more than you can chew. So quick example, and I'm sure everyone here has run into this, which is, say we're changing a method on a class. You're writing some code. And okay, we got to add this new behavior. And we're doing TDD because we're a bunch of XPers. Awesome. Oh, look, there's a test file. Hooray. All right, reading the test file. Where should this go? Oh, you know what? These two tests have the same setup as the new test I'm writing. So let's think up front. If I parameterize that test setup, the new test will be so easy to write. So let me do that. Okay, I'm parameterizing the test. Oh, you know what? The name of this class is actually kind of weird. We've switched from using DAO objects for our database things to actually using repository. That was kind of a standard we chose as a team. So you know what? Let's actually open up the production code real quick, change the test name or the class name. And we open it up and we say, oh, wait, why are all the method names taking in, or all the methods taking in the same parameter in all of the functions? 17 steps later, 40 minutes later, you've done a lot of big ball of mud changes altogether. It's kind of like the squirrel. Oh, I see this. Oh, I see this. Oh, I see this. That's where my brain kind of gravitates towards when I start working sometimes. And the problem is we get this big ball of mud commit that's containing a ton of things. Altogether, it might make the code better, but it's super risky. It's including refactoring along with behavioral changes, and it might even include unintended behavioral changes. If we actually want to roll back, like say we discover a big bug with it, we have to roll back the entire thing, or we have to pry inside of it and then figure out, oh, I want this, I want that. At one point in my career, I would do that with a lot of crazy Git commands, but there's a better way. So a mantra that I want to bring up from Michael Feathers, I think it resonates here, which is programming is the art of doing one thing at a time. This comes from his fantastic book, Working Effectively with Legacy Code. And I think, like we were saying earlier, even that situation that I called out, my brain sometimes goes there. And sometimes I have a little bit of a squirrel brain and want to do 19 changes at once, but it takes the discipline to say, no, I'm actually going to try to just do one thing. And the one part about working collaboratively is we can kind of hold each other to our disciplines. If my squirrel brain starts to take over as navigator or driver, somebody else in the mob can say, okay, what are we doing? We're doing like 7 things. And the person can say, oh, well, we're going to change the name of the class and we're trying to add this behavior. And we can say, oh, you just use the word and. Let's change that to doing just this one thing, getting it committed, getting it integrated, and moving on. So to eliminate this risk, we need to make everything we do with software smaller. This goes from not just the code we're writing, like we were just talking about, but all the way to how often we integrate, how much we're integrating, how big our deployments are, how big our stories are. For this talk, we're really going to focus on the bottom tier here of code all the way to deployment. But there's other great talks on stories and releases, making those smaller. But not enough talks on making the commit smaller, and that's what we're here about today. So first thing we're going to talk about is a concept called micro commits, which I first heard from Tim Ottinger. I think he's the guy who coined this. And a micro commit is a one small step, tiny commit that does one tightly scoped change. So some examples of what that looks like. Extract method total tax on cart. So it just all it does is extract a method on a class. Add gap spacing between items on a cart. So some just styling. And then last option here, -R rename variable subtotal. This is written with Arlo's commit notation. There's a ton of other Git notations. I feel like a lot of them kind of want you to break your commits up into small atomic one thing change. Arlo's commit notation, it's in my reference resources, but it actually goes really into the risk involved with each change, which kind of goes right into micro commits. And really, when I call it to the tiny commit, what I'm talking about is that it's one change. So for example, if we're changing how we want our code formatted, say we have an automated formatter, which we should be using instead of complaining in PRs, we would change the line that maybe changes our tabs from 2 to 4 spaces. In that same commit, maybe we actually run the formatter on the whole code base. That's probably a very big, I mean, every line of code would be touched, so that's a very big commit. I still consider that a micro commit because it's one change, running the formatter. And before I even knew what micro commits were, actually, you know what, before we do that, is everyone here familiar with micro commits or has used micro commits before? Yeah. Cool. So I was already doing this as part of my TDD cycle before I even knew the term. And this comes right from Tim's post about this, which is we do red, green, refactor, and then we integrate. And on average, usually means I'm committing every 2 to 5 minutes, especially when I'm working alone. Collaboratively, sometimes that changes, or if we're working on a problem that takes some understanding, that might take longer. But if we do in our normal TDD cycle, it kind of looks like that. Okay. Here's a screenshot from Baldur's Gate 3. This is a fantastic video game. This is pretty early on. And as you can see, this room has a lot of fun in it. There's a lot of traps and fire and death. And if you didn't save your game prior to touching the non-suspicious coffin in the middle of the room, you messed up. This room's got a lot of cool loot, or just like boxes and stuff you can loot. And if you didn't save after looting all those boxes, and then touch the coffin, yeah, you messed up. And how much does it suck when you're like, okay, I got to do the last 5 or 10 minutes of looting boxes. And that's why micro commits are kind of the same as saving your game. And in these large RPGs, Skyrim, any of these RPGs where there's basically a button bound to save, I am spamming that button every couple minutes. It's called save scumming in the gaming world. Micro commits are like save scumming. I don't want to have to repeat talking to that person. Because I already did it once, and nothing's going to change if I do it again. So, and just like how I constantly reload if something doesn't go my way in video games, I do the same thing with software. So git reset hard. Oh, it's the best git command. Here's a photo of this is Glacier Lake, I think, in Seattle. But every time I think of git reset hard, I think of this beautiful landscape because it really liberated the way I write software. Because of this, a lot of my coworkers like to say that I have a power of throwing spaghetti at the wall. And part of that, I would say, is because I feel very liberated. I can run git reset hard and get right back to where the build's working again. So I can try the dumbest, craziest, worst idea ever and just run git reset hard, and I'm back to good. And then as soon as we're kind of happy with our change, though, we can go to deploy it. And with micro commits, every commit should be deployable. And because of this, the work in progress we have should only ever be the last 2 to 5 minutes of any changes we made. And I say deployable, not releasable, because we might actually want to hide things. We can use techniques like feature flags or other features of hiding components where we still don't need branches or things to hide the code together. And by separating deployability with releasability, and like I kind of was already saying about branches, this enables trunk-based development. There's a lot of other things that are required for trunk-based development. But actually, I'm not looking at the chat here. Okay. Save scumming, something different, another. Okay. But trunk-based development is awesome. And, it's really where we just have one single source of truth and we're only pushing to that. We may have branches if, let's say, we have some kind of PR process. We might have temporary branches. We might have like spike branches for crazy ideas, but we're really only working against this main branch trunk. Every single commit on trunk should be deployable. So that if we ever want to release our software, if we're not releasing it every deployment, we just look at the most recent version on trunk and say, okay, we're going to release that. And what's great about this too is because we're doing micro commits where all of our changes are within 2 to 5 minutes away, and we're constantly integrating our code into trunk, that situation drastically avoids the chances of getting in merge hell, which I'm sure we've all been in. Merge hell sucks. And I will say, ever since I've been doing, especially trunk-based ping pong, but just trunk-based development in general, the amount of times I've had to go reach into Git and remember how to do all these crazy merge commands has shrunk drastically. Like I used to be like the expert on the team who would use Git reflog, would do crazy thing with Git rebase, would figure out how to take pieces of code and change them into different commits. I don't have to do that anymore. It's amazing. So a quick quote from the C2 wiki about continuous integration that I want to read. Development teams use code ownership to minimize conflicts among people editing. The longer engineers hold on to modules, the more important it is to minimize conflicts. What if engineers didn't hold on to modules for more than a moment? What if they made the correct change and presto, everyone's computer instantly had that version of the module? We would never have merge hell because the system would always be integrated. We wouldn't need code ownership because there wouldn't be any conflicts to worry about. Doing trunk-based development and trunk-based ping pong, like with micro commits. That sounds basically like the closest to this definition of continuous integration that I've ever seen. Okay, What's the hardest part of TDD, everybody?
Thinking up the next test to write.
Yes, figuring out the first failing test. You know, a lot of times that test might end up being ginormous and then we have to take a step back. So same thing. What is the hardest part of working in small steps? Figuring out the next small step to take. I didn't mention this earlier and I should have. I'm a really lazy person, and especially I'm a lazy developer. And when we are hitting hard questions like this, and I'm lazy, sometimes it might challenge my discipline and I accidentally want to take a bigger step because I'm really lazy. This kind of goes back to working collaboratively. It really helps if we're trying to work a specific way. If my lizard brain or squirrel brain takes in, somebody can help pull me out, see the forest for the trees. They can ask questions like, hey, are we working on one thing here? Or is there a smaller step we could take? Is there a way we can make this change deployable? But even still, even in a collaborative environment, we all might get stuck in a pitfall, taking way too big of a step, not being able to find our way out. So here's a really cool photo. This is from Agile Open Northwest. I'm showing it because story time. I was on a software team with a bunch of developers, XP developers. We were working remote and had to figure out how we wanted the remote mob program. There's multiple tools for doing this. I know like VS Code has live code, and JetBrains has their own version of that as well. But most of us have used a different tool in the past, MobSH, and we started off doing that. We figured we would try this and then kind of experiment. Is anyone using MobSH right now at work? Yeah, sweet. It's an awesome tool. I love it. So it makes it dead simple for working with a mob. And I think what I really like about it is if somebody's never mobbed before, you can basically get somebody understanding how it works right away. And for those who haven't used the tool before, here's a quick way of how it works, but a lot of us have already used this. Basically, let's say that we have Carl and Maria, and Carl's the first typist or driver, and Maria is navigating. Carl will start a mob branch. That'll be mob start, or like in our situation, we actually had a multi-mob setup. We had about 3 to 5 mobs going on at the same time. So because of that, when you do mob start, it usually takes the branch you're on. It creates that shadow branch, or main/mob. But since there's 3 or 5 of us, we all couldn't be on main/mob. So we do the second part, which is what is the branch name? So we do that. That starts the mob branch. Maria navigates Carl through some changes. And then the other nice thing about this tool, my favorite part of the tool actually, is that it sets a timer, which I believe is 10 minutes by default. Timer goes up. Carl then, they need to rotate. So Carl runs mob next and then takes Carl's changes, puts them in a commit called whip, and pushes them to that remote branch that the mob tool has created, and then checks Carl back to main. Cool. Maria then would run the same command that Carl did to basically check out those changes. And then they would continue. And they'd be using like Zoom screen share or whatever video editor or video screen share. And now let's say that Carl navigates Maria and they're ready to commit. So then Maria would say mob done, would then take the changes on that remote branch, merge them into main, but put them in staged, not in a commit. So then Maria would then run git commit -m, let's say extract method total tax on cart, and then push. So all fine and dandy, but what if we want to commit a change before the first rotation timer's up? Going back to micro commits, say we have a rotation timer of 10 minutes in the mob tool, but 2 minutes, we're ready to commit. This is what this would look like. Person would mob start, and then, oh, we ready for a change? Okay, that same person then would hit mob done and git commit. Going back to I'm lazy, this is an extra 2 steps. because it's an extra 2 steps, that's going to incentivize me differently because I'm lazy. So what would instead happen is, you know what? Yeah, let's just keep going. Oh, timer's up, time to rotate. All right, let's keep going. Oh, timer's up, time to rotate. And then someone would be like, wait a minute, we should have integrated 20 minutes ago. And then, okay, sure. Big ball of mud commit, push. So this additional 2 steps, it's kind of that cost of integration. If it's high, we're going to integrate less because humans are naturally lazy. And then because we're integrating less and the mob tool's making branches, we're actually integrating between multiple parallel streams less too. On a team with 1 mob, no problem. On a team with 3 to 5 mobs like we had, we sometimes ran into some merge conflicts. Because we were an XP team, all of us were refactoring nonstop. There'd be times where we'd accidentally refactor the same files, refactor the same things. One time in particular, there was basically a big problem that it influenced kind of 2 places in the code base. 2 mobs tried to do the same refactoring, but slightly different. And it was 30 minutes of changes before they realized they did that. Then the mobs came together and said, oh no, well, we've already built new code on top of that change. But I kind of like the way you did it better. If we were integrating every 3 to 5 minutes, like without the mob sh tool, we would have noticed this earlier. So I know I kind of maybe talked some smack about the mob sh tool, but I still really like the tool. But it was kind of problematic in this instance because it was making that remote branch and because it kind of added a couple extra hoops. So instead we experimented. What if we just pushed to trunk and then pulled? And this is what this kind of looks like. So we'd still have the timer going to make sure we're rotating early and often. I think it was usually like 10 or 5 minutes. The typist or driver would pull the latest code down. Okay, we're ready to, the timer goes off. Okay, are we at a commit point? Maybe. Okay, well, let's try to get to a commit point. Okay, now let's commit. And now we're gonna push, and then the next driver would pull it down. So this works pretty well, except we kept kind of hitting this question of like, should we rotate? When do we rotate? Oh, you know what? There's 2 minutes left in the timer. What do we do? I'll keep going. Timer goes off. Oh, we're not ready for a change. 7 minutes go by. I probably should have rotated then. Oops. And for those, you know, who've paired a mob, the more we rotate, the better it feels in terms of engagement, in terms of making sure like we're 6 hours later. That is, I think there's been a time where we've gone like an hour and a half trying to do like a hairy refactoring, and then everyone kind of feels sunk cost. So this kept happening. What, you know, the timer goes off or we're ready to commit. When do we rotate? One day, me and Brett Schuart, we were just pairing. And it was kind of effortlessly. We were not asking ourselves that question. We just kept kind of pushing code, rotating, pushing code, rotating. It looked like this. One person, or we would write a test together, make it pass, integrate, rotate. Then the next person to pull it down, we'd refactor, we integrated, we rotated. We pulled the code down or rotated, refactor, integrate, rotate. And it kind of looked like this for 2 hours. And it's hard to describe it here, but it felt very different from the previous flow. And this is where after, I think we did a little retro that day and we're like, this felt like a different thing. And that's what we're calling trunk-based ping pong. So the way I define it is we can rotate anytime we can commit and push our changes directly to trunk. This does assume we're working in small steps so that we're actually rotating early and often. So going back to that micro commit cycle, it looks like this: red, green, refactor, integrate. That's our rotation point as well. And the thing that we kind of did that was fun was usually the step from red to green is a little bit longer than refactors. So we do red, green, deliberately leave maybe, you know, a gross variable name or a gross function, still rotate, And then it made it very obvious what the next change would be, the next smallest step. Cool. So that is basically trunk-based ping pong. And I know kind of talked a lot about it. And I'm a big believer in show rather than tell, even though I just told you all about a bunch of stuff. So now we're going to play a little bit of show. So we're going to do Fizz Buzz, everyone's favorite kata. And me and Anthony are going to do 5 minutes of trunk-based ping pong, just so folks can see it happen. And I'm sure we all know what Fizz Buzz is, but here's a nice little diagram that I stole from John Reed, who just walked away, about it. So on 3 we fizz, on 5 we buzz, and on 15 we fizz buzz. Okay, so I'm gonna stop sharing and we're gonna pull the code out. I guess, yeah, and we'll have some questions. I think while we're actually writing the code, if anybody's got questions, we can go for it then, and then we'll have a little bit of time for some questions afterwards as well. Just give me 2 seconds.
Who's going to start? Do you want to start or do you want?
Why don't you start? Just because I gotta rearrange the monitors here for a sec. The bundle of wires by my left shoulder is regular, what is that? Cable that I need to cut or do something with because it looks terrible. Thank you for reminding me. Cool. So we've got ourselves here, Fizz Buzz test. You just ran the first test?
I did. Yeah.
Sweet. So I think for the first test case, for the integer 1, we want the string 1. So why don't we just change first test to 1 gets 1. Cool. So then in this case, yeah, instead of assert true, let's create our FizzBuzz object. And I haven't written Java. This is Java, by the way. Okay, and then we'll just have a dot print method, maybe.
Say that again. Did you say print?
Yeah, print. Why not? And then we pass in the number 1. And then at this point, our code is already not compiling. But yeah, we can has is equal to the string of 1. Cool. So yeah, let's create print. Awesome.
Oh,
I love that it thinks it's a Boolean. Thank you, Java.
It's a Boolean.
It's Boolean. Oh, cool. Yep, number. And then for now, let's just do the simplest possible thing, which is hard code returning the string 1. Or actually, yeah, you're right. Let's actually see it fail first. That's probably a good idea. Because a test we haven't seen fail is a liar.
Okay, expected 1. Got empty string, so we'll start with this.
Yep. Okay. And now following our rules of trunk-based ping pong, we're at a commit point. We could actually deploy this to production, primarily because nobody's using this code. So we're going to commit. Yep.
Good enough for a message?
Good enough. Yep. And we'll push and we'll see if you still got push permission. And you do. All right. And now I'm going to steal screen share. And this is probably going to be slower than next time. Give me a sec. All right. Oh, and thank you, Zoom. 1 second here. Okay. I'll pull the changes down. I should be able to run the tests. And obviously, oh, it is running. 1 gets 1. All right. What do you want to do next?
So we could do 2 to force us to change the hard-coded 1.
Okay. 2 gets 2. Okay. And
1 pass, 1 fail.
okay. Now what would you like me to do?
So I guess the simplest thing we could do is convert the number to a string.
Okay.
So that's string.
Oh, value of. That's what it was.
Value of, yep.
Yeah, the fun thing is I haven't written Java in a hot minute. Okay. And it passes. So now we commit
Mhm.
and we rotate. 2 gets 2. All right. Yeah, the one nice thing about Zoom, if you can have the setting of steal screen share, it makes this a lot faster. Because we're rotating so often, we want to make the cost of rotating basically 0. In person, this is very easy because you just, get up and move.
Okay, so I will pull down those changes. Now 2 gets 2.
Okay. From the mob, what do we want to do next?
Got some duplication in the test.
Got some duplication in the test. What about a parameterized test? Does that sound cool? Okay. So the parameterized test, I think it's at parameterized test.
Yeah. So how we add it as a third test and then delete the first 2?
Yeah, I think that's a good way to do it. So at parameterized test, I think we can, oh yeah, look at your AI is helping you out. CSV source, I think is the easiest one where we kind of want 2 different types of input. So 1, 1.
Should we start with that one, or do you want to do?
Let's just start with 1. Many of 1. Yeah, that's a good.
We still no. Yeah, so now we do. We'll just for now we'll just say FizzBuzz.
Yeah, works with me. And then int number and then string output or expected. Actually, that was a way. AI is smarter than us. It's been proven.
Did it give us expected?
It did, yeah. Yeah, looks right. If we run that, I'm actually curious. It's been a while since I've done this. What does that look like in the?
So let's run it and see what it looks like.
1, 1, 1. That's kind of weird to read, but it's totally fine.
And we can change that. I can't remember. We'd have to look it up, but there's a way. I think it's
arguments to parameterized test.
Oh, okay.
Oh, yeah. Okay.
That's fine. Cool.
Okay. Well, should we do?
Yeah, let's try.
And it's that. Maybe that'll. I don't know if this will make it easier to read. Let's see. Not exactly what I was expecting, but
2, 2. Okay. And now at this point, and actually we didn't see them fail. Could you make it 1, 2? If we just see that one fail, I'm convinced that it is working correctly. Okay, cool. Yeah, let's delete the other tests and commit. Okay, I'll pull it down. Maybe do one more rotation.
Sure.
Boop. All right, what's next?
I think we go after Fizz.
Boop. Okay.
I think the simplest thing is just to have a conditional before the return that just checks if number equals 3.
Bad AI.
Oh, look at that. Did you see what it did there?
Yeah, bad AI. This is where for practice things. I mean, I thought I turned it off too, which is funny.
AI likes the big ladder. The big
It does like the big ladder. It's true.
I know this one.
Okay, and that works. And this is where we can commit and rotate. 3 is Fizz. 2 lines of code. Okay. I think We can do one more. We'll do one more. Why not? Now let's do 6 is fizz. We'll just jump ahead because it's more interesting. And this will fail. Sweet. And yeah, I think that now we can actually, we have the triangulation. Now we do the real implementation where it's modulo 3. Technically not the simplest thing. We could have just said if it's 3 or 6, but
That's fair.
yeah.
So I guess part of being in the mob is deciding how big of another step you want to go, right? So if people
Yeah.
are comfortable making that, doing the modulo 3 now, or do they want to see the 3 or 6?
And I think that's part of it. Like, FizzBuzz is such a toy baby problem. We all have probably done this a million times, but in our day to day, it's nice to know how low can you go? What is that smallest step we could actually take where we can write code and actually commit it, integrate it, and deploy it to production? But cool. I think let's commit, push this just because it feels good. And then we'll go back to the rest of the talk. Any questions or thoughts or anything for folks who haven't done this before?
Maybe this is coming up in the rest of your talk, but like when you talk about, if you've gotten to that point where you're like, this ended up being bigger than we thought it was going to be,
Mhm.
like what's the like emergency release there where you're like, oh, this refactoring could have been 2 smaller things or something like that.
Yeah. So I think that's where having and being liberated by git reset hard is the thing I usually pull to in that case. So it really is like we realize we've gone too far. At that point, if you know you've gone too far, you probably have an idea how you could break this problem up more. And because we're trying to, at a discipline level, integrate every 3 to 5 minutes, hopefully we're not too far out where we feel the sunk cost and instead can be like, you know what? Let's get reset hard and let's start over this again, but this smaller version of what we were trying to do. And I'll be honest, sometimes I feel the sunk cost and don't want to do that. And I'll keep going and deal with the risk, but I can incur the risk. But there's times where you incur the risk and you just keep there's these tests are failing. Oh, I don't know why this is broken. And sometimes that risk, hurts. Going back to the ladder, that ladder analogy on the right. It's like you fell off the ladder. And sometimes you're actually going to fall lower where you've left the system in a worse state. So really feeling liberated by git reset hard and just accepting that a lot of times the first way we try to approach a problem is the wrong way. So go with that assertion and just try to change course as you can.
Cool. Thank you.
Cool.
There's an interesting dynamic between, like you were talking earlier about like pair programming ping pong and how this is different. And it's obviously different because you're integrating to a trunk that is potentially releasable between every step, which is not how you do pair pair TDD. You're passing it while the test is failing, for instance. You wouldn't do that here. And the thing that I've always, the thing that's different about pair programming ping pong is that there's no longer like a driver navigator that gets erased because you're just, okay, I'm going to write this. It was almost an adversarial, like I'm going to really F that guy up and, write a test that fails that he can't make, this is almost a competitive thing. With this, you still have a driver navigator relationship, at least in the way you and Anthony did it. And, the way that you and I have been doing it.
Yeah, I agree. It's and I think I was talking to somebody about this before and he's like, this isn't ping pong because like ping pong is we're literally playing a game against each other. However, the reason why we picked the word trunk-based ping pong is it still it had that feeling like of flow.
Yeah.
But to get everybody in, like with TD ping pong, that's where person A writes the failing test. Person B, they rotate at that point. They make it pass. And then person B will write the next failing test. Person A will then, they rotate and person A makes it pass. And like you're saying, that really isn't driver navigator. It's more of, oh, it's your turn. Oh, it's your turn, which is fun and different.
Yeah.
And yeah, they can refactor whenever the tests are green. But this is the, like how I've called out the difference is TD ping pong's rotation on red, trunk-based ping pong's rotation on green. And with a lot of people working remote, like me and John are working and doing trunk-based ping pong, the benefit of it rotating on green is we can actually deploy that commit right away. So we're getting trunk-based development, we're getting micro commits, and we're integrating early and often. In person, like I'd be interested actually, like in person, trying an hour of both and seeing kind of how that felt.
Yeah, I hadn't considered the remote dimension to this. Is that TDD ping pong rotating on red, there was much less trouble with that before remote because you didn't pass through the source control system.
That's right.
Yeah. But with MobSH, you totally could. Actually, that'd be kind of a cool experiment is, use MobSH and try the rotate on red. But again, I'm lazy, so it'd probably be too many steps for me to want to do it too often.
Another question about MobSH though is I haven't looked at, I could look this up, but does anybody know, does it have a setting where it doesn't go to a branch, where it does push straight to the trunk? Because I like it when my computer says move.
It has, you can set the timer though. I know that.
Yeah.
Like I've used that for the timer prior.
Oh, just using the timer.
Mob timer.
And then just use use get anyway. Yeah.
Yeah, I don't know. I've thought about like going in or reaching out to some of the MobSH folks and seeing if there's like a version of that. Like maybe there's a workflow. Because you're right, like it's nice. It brings in the timer. It does other things.
There is a setting for like the branch that it uses, like the branch name. I just wonder, can you set it to none? And then it just commits to trunk.
Yeah. Oh, that would have been nicer instead of typing in the branch name. Okay, I did not know that. I've learned something new today. Cool. So yeah, I mean, that's basically the talk. That's the technique. I think what I really like about trunk-based ping pong and from doing it a bunch is it bridges two things that are really close to my heart in terms of writing software, which is that we're working collaboratively and we're working in small steps. And not just that, we're incentivized to do both together. So thanks. And here's a link. Here's me and my dog, Sweepy. And then here's a link to the resources. Oh, cool. Any other questions?
Awesome. Thank you, Kody.
Yeah.
Really cool talk. All right. Well, if anyone doesn't have anything else, we'll wrap up. Good to see you all. Hope to see you back again next month. Next month's talk is going to be about etudes. So it'll be...
What is it about?
Etudes.
Oh. Cool.
So,
like music?
Like programming etudes. Similar to code codice.
Oh, okay, cool.
All right, everyone. Great to see you all. Hope to see you again soon. Take care.
Nice work, Kody.
Yep.
Thanks.
Thanks, everybody. Have a good night.